So what we're going to be doing in these workshops is a series of hands-on learning opportunities for the students to be talking about computational thinking. So we'll be doing one on sequencing, conditional statements, loops, and then variables. So they'll be able to sort of understand what these different concepts are, what the definitions, the key words are, and be able to apply these concepts in practical situations and provide examples for them. So sequencing is important because it's really the basis of coding and programming. You have a lot of algorithms, a lot of step-by-step pieces that you're putting together to perform some sort of task in code. So understanding how you build those steps, how that order is created is really important to understanding how you program, and that it follows a very logical step-by-step order for that. So for teachers, while you're working in this workshop, it's really important that students are really following step-by-steps. They're being very detailed in their steps. You don't want them to just be saying like, oh, in a situation where you're programming a robot turn right, how many degrees are they turning right? So it should be a lot of them trying to figure out what are those really specific details in those steps that they can do for the sequencing. So guys, today we're going to be doing something a little different from our regular Kano sessions. We're going to be doing a series of hands-on activities, some games that are all around coding and programming for today. So you might be working in pairs, you might be working in groups, but you're going to be working together to understand different type of coding and programming concepts. So we're going to have 4 different types of workshops today, and you're going to be learning about sequencing, you're going to learn about loops, conditionals, and variables. So it's okay if all of those things don't sound familiar at all, or maybe they do sound familiar, but we're going to be learning about them today. We're going to see like what kind of games we can play to understand those different types of concepts. So to start the day off though, I just want to go over a couple of ground rules for you so you can kind of understand what we're going to do today. So a lot of today we're going to be doing, you're noticing you're sitting in tables. You're going to be working with your group. This is sort of your group you will work with for these sessions. So you're going to be collaborating together. You're going to be working together to try to figure out some kind of complex situations. So I might give you a scenario and I'd be like, you need to figure this out. And I'm not going to really help you. So what you need to do is work together and try to see if you can solve it. So you think of yourself as a little tiny team, a little tiny unit to try to solve these different type of problems together. The other thing is we're going to be going over different types of definitions. We are going to be creating engineering journals for the first 5 minutes. You can use these to record your notes, your thoughts, any sort of like ideas you have. You're going to have a bunch of pieces of paper that you can write and record this in. What I want you to do is write your name on the front. You can name it whatever you want. You could call it like Jack's Awesome Engineering Journal or My Journal for My Thoughts. I'm only going to give you about 3 minutes after the journals are out to decorate and add as much as you want so that we can start the activities. So sequencing is when you're essentially following an order, step-by-step instructions to be able to do something. Why is it important that you follow a sequence for things? Why would I need to follow steps in an order? Yes?
Because if you might get it wrong in the wrong order and then like it could go wrong and then you could like do something, you can mess it up.
Yeah, maybe when you do something in the wrong order, you mess it up. It doesn't do what you're supposed to do. So let me ask another question to go with this. I'm going to leave it blank and I want you to fill in the word for it. So computers are very blank. What word would you put in for that blank? Yes?
Complicated. Mysterious.
Mysterious. So I think computers are very stupid. Do you agree with me? Yeah. So if you've been on the Kanos, you probably agree with this because of MakeArt. But Kano and computers in general are really stupid. They only do exactly what you tell them to do. So if you say, turn around in a circle forever, I would turn around in a circle forever until my batteries die. I'm getting really dizzy doing that, so I'm not going to do that. So that's why it's really important for sequencing to follow step-by-step orders and then be very, very detailed on the instructions you're giving for that code and that program. Because if you don't, the computer, it's just going to freak out. It's not going to know what to do. What I'm going to do is I'm going to give you a very detailed instructions. I'm not going to let you ask questions. I'm just going to give you the instructions, and you have to do as the instructions say. So try to not, you can't talk to your partner or anyone in the group. I'm just going to give you the instructions, and you're going to just do as the instructions say. So it's very important that you pay very close attention, because I'm only going to give the instructions 2 times before I move on to the next one. Okay? So we're going to start. Everyone should have a pen or a pencil in their hand. Your first instruction, draw a dot in the center of your page. So draw a dot in the center of your page. Second instruction, starting at the top left-hand corner of the page, draw a straight line through the dot, finishing at the bottom right-hand corner of the page. Third instruction, starting at the bottom left-hand corner of the page, draw a line through the dot, finishing at the top right-hand corner. So can I have everybody hold up your engineering journals to see what everyone else has done, to see if you've all done the same thing. So look around. Does everybody's look pretty similar? So for this little drawing activity, you were the computers. I was giving you a set of instructions, and then you had to follow them in a detailed way to be able to draw the same picture. So luckily, we've all been able to reproduce the same drawing because we were able to follow those steps step by step, and they were very detailed. Now, I'm going to issue a challenge to one person in the class. So I have another drawing. Now, I want a student to come up and give instructions for that drawing. So this is the drawing. You're going to tell them to draw. But we got to hide it. You can't let anyone see it.
Draw a smiley face.
Oh, good speaking, projecting voice.
Draw a face like you're not happy. Draw a face like you're really sad.
I want everyone to hold up their engineering journals and show their pictures to the group. And kind of try to look at everyone's pictures. You drew it differently. So although we had good instructions, I can clearly see that we have a smiley face, we have a sad face, we have a frowny face, but this is what the picture actually looked like. So this is where our next activity will come into play. Now, if you look at the front of the room, you might see that there are 2 cushions here. So there are 2 cushions. What we are going to do now is we are going to do a simulation where one of you is a robot and the rest of you are programmers. So what you have to do as the robot, this group, you might have to come closer to look, but you're going to start here on this black line. And your job is to get your robot in your group to go around the obstacle course exactly like this. I'll start facing forward on the black line. I'm going to go around to the right for the first one, then to the left, go fully around, then I'm going to go to the right, and then I'm going to stop on the black line. I don't have to turn around, I just need to stop right here. The other difficult part about this is that the robot is going to be blindfolded. Yeah, so the robot's not going to be able to stop. If the robot touches this, it's crashed. So you only get 2 crashes per run. So what you'll do is you'll have your robot here at the starting point, and then my programmer is going to read the instructions for how I'm going to move across the obstacle course. So if my programmer says take 1 step forward, I'm going to take 1 step forward, take 1 step forward, oh, okay, I crashed. So you have to be very detailed in the instructions you're giving the robot so they don't crash. Now we are going to do the real runs now, where I'm going to be blindfolding the robot. But you're only allowed to come up if you have instructions written in your journal that you're reading. You can't just come up to the front and tell your robot, turn left, turn right, turn left, turn right. You actually have to have something on your paper that you're reading. That is your code to your robot.
Move forward 2. Turn like forward.
Crash. Okay, there's actually an easy way to do this whole entire obstacle course in only 3 instructions. So you can complete this whole entire obstacle course in 3 instructions, but I'm not going to tell you how to do it. So if you can figure it out, then come up to me later, but I'm not going to do it right now. So again, what we were doing today was sequencing and following very detailed steps. So can someone just tell me in their own words what sequencing is?
Sequencing is sort of like repetition, and because it's sort of like an 8 when you go round. So it's basically you do one part of the 8, then the other.
Exactly. So yeah, these are all different things to show sequencing in computer science, and then when you use it in the real world. So you might find an obstacle course where you have to give very detailed instructions. Maybe you're doing a drawing where you have to be able to follow instructions so you can reproduce the same piece of art. Maybe it's following instructions to make a peanut butter and jelly sandwich or cook something. But in life and in coding, you have to follow very detailed step-by-step instructions to be able to get something or a finished product. So that is our sequencing activity. So if you want, before we take the break, if you can write in your journals sort of a summary, what is sequencing and what did you like about this activity or what was hard about it. So just kind of summarize your thoughts for this activity for maybe about 3 minutes. And we're gonna take a small short break before we go on to the next activity. So for the sequencing class, to see if the kids really understood what we were trying to get across for what a sequence is, a set of instructions that you follow that are really detailed. I think the they've got it moment is really if I can look at their journals and see the code that they've written. They can sort of say what they want to say, but I think the part where you're looking at their engineer journals, you're seeing that they have like an instruction, a very step-by-step instruction written down, and then it's a detailed instruction. So we had one student that had, I can do 90, I can do 180 degrees, and that was maybe step 7 of steps 1 through 30. So it was very detail oriented. There were multiple steps, multiple sequences that you had to follow to get to that point. So I think for a written portion, that's what I would be looking for, like, okay, they got it. I can see this produced. But I think if they were verbally telling me, trying to explain to me what sequence is, what they would do for that is that they can sort of provide a definition of it's following a sequential order in very detailed steps. That if they can at least articulate that portion of it to me, then I think that they were able to get it more so, if they can articulate that definition to me. I think for teachers that are teaching sequencing for the very first time, it's really important to give, a lot of time for the students to really practice a hands-on activity to understand sequence. Students do understand that, I have to follow instructions, I have to go in an order to be able to complete something, but sometimes they don't realize how detailed they need to be. So giving students time to be able to debug and figure out what they did wrong in a scenario is really important. And that debugging process, that trying to figure out what went wrong, might take a little extra time, and you might want to give them the answer immediately, but it's more constructive for them to kind of figure that out as a group, how to debug and figure out what went wrong in their problems. So I really think that when you're doing a lesson, especially on computer science, it's very important to try to mix up the different learning styles. Computer science and coding can be very you and the computer. It can be very impersonal, it can be very by itself, and some people learn really well from that, some people don't. And I think being able to have an activity where you're moving around, you're engaging with your partners, you're engaging in group learning is a way to kind of make it stick, because then when you're referencing that event, you'll always remember that activity where you were blindfolded and you're trying to move around and go through the obstacle course. And typically when I do the coding curriculum lessons, I always start with the sequencing lesson, so then I can reference it throughout the whole entire coding curriculum, because I'll be like, hey, you remember that time where you were blindfolded and then you ran into a chair multiple times? They all remember that, they all enjoyed that activity. And it is a high energy activity. It's gonna be loud, you're gonna have a lot of kids by the obstacle course wanting to do something, and that's perfectly fine. Of course, you wanna manage that energy and try to control it as best as possible. But that high energy is what they'll remember about the activity, and you'll be able to reference it throughout the whole entire class.